Hello, Chem 20s. We're back for Boyles Law Part 2. So, jumping into example number 2, I would like you to pause the video. I would like you to write down on the left-hand side at least a list of the variables from the question, check the units, make sure the question is ready to go, and then check back with me by unpausing. Okay, example 2 says, a cartridge of carbon dioxide is punctured and released into a balloon at STP conditions. The original cartridge has a pressure of, so this is going to be our P1, 2,165 kilopascals, and a volume of, so V1 of 147 milliliters. We want to know what is the final volume of the balloon. So we want to know V2. Now the question does tell us P2 because we started at this pressure, but then when it was punctured, it released at STP, standard temperature and pressure. So the pressure at STP is 101.325 kilopascals. And remember, you have that in your data booklet on page 3. Now, this is the time where we take a look. Both pressures are in kilopascals. My volume is in milliliters. I'm happy with it in milliliters. That just means that when I get my answer is also going to come out in milliliters. So for the first mark, I'm going to write down the memorized formula. P1V1 equals P2V2. On this question, we are trying to find V2. So to get V2 by itself, we're going to move P2 to the bottom. So V2 equals P1V1 over P2. 1 mark for having the original and the moved around formula. We're now going to substitute in our numbers. 2,165 kilopascals times 147 milliliters divided by 101.325 kilopascals. Your second mark is for having the unit substituted in with the numbers, and we are going to solve for V2. So again, we're going to type this in. 2,165 times 147, enter, divided by 101.325. And the number I get is a large number, 3140.93262 kilopascals on top and bottom. My unit's going to come out milliliters. If I go back to the original question, 3 sig figs, 4 sig figs. So we are going to be allowed 3 significant digits. That means I'm going to have to do scientific notation. So 3.14 times 10 to the 123 milliliters. Now, there is another option for this answer, and that is instead of giving the answer in milliliters, although this is how it came out in the calculator, we can change it to liters. So if I want to change it to liters, remember there's 1,000 milliliters in 1 liter. So I would times by 1 liter on top, divide by 1,000 milliliters in the bottom. So I'm going to divide by 1,000, and the answer is 3.14 liters. Either of these answers are acceptable. Again, you get your third mark for correct answer with a unit in the correct number of significant digits. So 3 sig digs, 3 sig digs. Does the number make sense? Pressure went from 2,000 roughly to 101. Pressure went down by a lot. Volume goes from 147 to 3,140. As one went down a lot, the other one went up a lot. Okay, let's try another question. Again, you should be pausing, trying this question for yourself. So the question says, if a gas has a starting volume, so V1 of 175.00 milliliters, and a pressure, so a starting pressure of 113.125 kilopascals, and experiences an increase in pressure to So P2 is going to go to 116.710 kilopascals. What is the final volume? So we are trying to find final volume. Now, if I take a look, kilopascals, milliliters, my answer is going to be in milliliters. So 1 mark for the formula. P1V1 equals P2V2. We are again solving for V2. So we're going to move pressure to the other side into the denominator. V2 equals P1 over V1 P1V1 over, P2. So 1 mark for the two formulas. We're going to substitute in our numbers. 113.125 kilopascals times 175 milliliters divided by 116.710 kilopascals. So 113.125 times 175, enter, divided by 116.710. And my full calculator number is 169.6244966 kilopascals on top, kilopascals on bottom. My unit's going to be in milliliters. I go back to the original question, 5 sig digs, 6 sig digs, 6 sig digs. So this is a rare large number of sig digs. So we're going to put it into 5, 169.62 milliliters. Let's check to make sure our number makes sense. So pressure goes from 113 to 116. Pressure went up. I would expect volume to go down. So my number would be less than 175 milliliters. My number is 169, so it did go down. I can assume I probably did this question correctly. Now, the question also says express in liters and milliliters. So I've already expressed the answers in milliliters. I'm going to remind us that for every 1 liter, that is 1,000 milliliters. So I'm just going to take this number and divide it by 1,000. I could also write it as 0.16962 liters. It asks for both answers. I'm going to give both answers. You do not have to go all the way back to the first step and change this to convert your answer. You can do it once you finish the question. Okay, let's go and do the very last question. This one's a little bit different. Please read it carefully. The pressure of 2.40 liters of chlorine gas. So my pressure is 2.40 liters. Sample of chlorine gas is 101.1 kilopascals. So that's going to be, oh, well, I goofed that. So let's do this. And let's fix this up. So my volume is 2.40 liters, and my pressure is 101. I just misread the question, 0.1 kilopascals. What is the final pressure? So we are trying to find, and again, I'm struggling. So let's fix this. This is my P1. So what is my final pressure? I think I will, if the volume here's the trick, decreases by 0.7. So my initial volume was 2.4. If it decreases by 0.7, I have to subtract 2.4 minus 0.7. And my value is 1.70 liters. Be very careful how you read this question. Okay, P1 V1 equals P2 V2. We are solving for P2, which means volume's going down. P2 equals P1 V1 over V2. 1 mark for the formulas. We're going to sub in 101.1 kilopascals times 2.40 liters divided by 1.70 liters. Liters on top, liters on bottom. My answer for pressure is going to come out in kilopascals. So 101.1 times 2.4, enter, divided by 1.70. And my answer is going to be 142.7294118 kilopascals. I go back, 3 sig digs, 4 sig digs, 2 sig digs. So I'm going to have to put my number in scientific notation. 1.4 times 10 to the 12 kilopascals. Now, this question also asks to put the answer into millimeters of mercury. So you were supposed to memorize the conversion. So the conversion is, there is 760 millimeters of mercury in every 101.325 kilopascals. So they will cancel. My answer is going to be, take the full calculator number, times by 760, enter, divide by 101.325, enter. And we're only allowed 2 sig digs, so this would be 1.1 times 10 to the 3 millimeters of mercury. If this question happened on a quiz or a test, 1 mark for the formula, 1 mark for substitution, 1 mark for the correct answer with the correct sig digs and units. I would see some sort of conversion, and 1 mark for your second answer, incorrect, 2 sig digs and units attached. Hope this lesson went okay. This is part 2 of Boyles Law. Again, please watch them in the correct order and refer back anytime you need. Thank you very much.